Venus, the most hostile planet in our solar system, a world of scorching temperatures, crushing pressures, and a toxic atmosphere. It's a place where dreams of life seem to instantly wither and die, a true testament to planetary extremes. Today, we're asking the unthinkable. Could humanity terraform Venus? And if so, should we? Venus doesn't just resist life, it obliterates it. Sulfuric acid rains from toxic yellow skies, not in drops but in a constant corrosive downpour. It melts metal, devours stone, and if the searing heat doesn't vaporize you, the crushing pressure will flatten you. Venus doesn't just kill life, it shreds machines too. Dozens of robotic probes, twisted, melted, crushed, now litter its surface like bones on a battlefield. Even our best engineering couldn't endure the heat and pressure, temperatures that melt lead. A constant, unrelenting oven, hot enough to turn solid metal into molten puddles. It's a temperature that defies our everyday experience, a true hellish landscape. And yet, scientists believe we could live there. Despite all the challenges, the extreme conditions, the seemingly insurmountable obstacles, the dream of Venus as a future home for humanity persists. A twin of our own blue planet? It's a question that sparks the imagination and challenges the limits of our technology. In this video, we dive headfirst into one of the most outrageous questions science has ever dared to ask. Could we actually terraform Venus and make it humanly habitable? Not in fantasy, not in some distant sci-fi novel, but with real-world physics and technology we may already be developing. From floating cities in the sky to cooling the entire planet with orbital mirrors, we'll explore radical ideas grounded in real research. But here's the twist. Some scientists believe Venus, not Mars, may be our best shot at a second Earth. Could that be true? Could humanity survive, even thrive, on the deadliest planet in the solar system? Today, we're pulling back the curtain on the most daring ideas ever conceived to tame the most hostile world in our solar system. From orbiting sunshades that could dim the planet's relentless heat, to engineered microbes designed to rewrite the very chemistry of Venus's atmosphere, and even futuristic floating cities suspended in the only survivable layer of its skies. These aren't scenes from a sci-fi movie. They're serious proposals. Can we truly transform a planet where temperatures melt lead, where the pressure would flatten a submarine, and the rain is made of acid? Let's travel across the 92 million kilometers of space separating us from Venus, and ask the unthinkable. Could humanity take this cosmic furnace and forge it into our second home? Because for all its violence, Venus holds a strange promise, a blank canvas for the boldest visionaries of science and survival. Venus is nearly the same size, mass, and composition as Earth. In many ways, it's our planet's twin, but something went terribly wrong. While Earth became a cradle of life, Venus spiraled into catastrophe, a runaway greenhouse effect that transformed a once Earth-like world into a suffocating inferno. Understanding how that happened might not just help us terraform Venus, it might help us protect Earth from suffering the same fate. Surface temperature? Over 475 degrees Celsius, hotter than Mercury. This isn't just a warm day, it's an inferno. A temperature hot enough to melt lead, bake rocks, and vaporize water instantly. A truly inhospitable environment. Atmospheric pressure? 92 times Earth's. Imagine the crushing weight of nearly a kilometer of water pressing down on you. That's the kind of pressure you'd experience on the surface of Venus. The air? 96% carbon dioxide, an atmosphere so thick with CO2 that it traps heat like a runaway greenhouse, creating the extreme temperatures we've already discussed. Suffocating and toxic, it's an atmosphere utterly incompatible with human life. If the heat and pressure weren't enough, the atmosphere is also filled with clouds of corrosive sulfuric acid, raining down on the surface and adding another layer of hostility to this already challenging world. Winds stronger than hurricanes. High in the atmosphere, winds whip around the planet at incredible speeds, creating a chaotic and turbulent environment. These winds contribute to the planet's extreme weather patterns and make exploration even more difficult. No spacecraft has lasted more than 2 hours on the surface, a stark reminder of the challenges of exploring Venus. These robotic pioneers succumb to the planet's extreme conditions, their brief lives cut short by the heat, pressure, and corrosive atmosphere. Venus isn't just uninhabitable. It's hostile to life in every way. It's a planet designed to destroy, a world that actively resists any attempt to tame it. A true testament to the power of planetary forces. To even consider terraforming, we must cool it down. The first and perhaps most daunting challenge is to lower the planet's surface temperature from a lead-melting 475 degrees Celsius to something more Earth-like. One proposal, giant orbital mirrors to block sunlight. Imagine a vast array of mirrors positioned in space between Venus and the Sun, reflecting away a significant portion of the solar radiation and allowing the planet to gradually cool. Another, bombarding Venus with icy comets to lower its temperature. A more dramatic approach involves redirecting icy comets to collide with Venus, delivering vast quantities of water ice and helping to cool the planet and potentially form oceans. It would take centuries, maybe millennia, but it could work. Terraforming is not a quick fix. It's a long-term project, a generational endeavor that would require unwavering commitment and technological advancements beyond our current capabilities. Next challenge, the atmosphere. Once the planet has cooled, the next hurdle is to transform its thick, toxic atmosphere into something breathable. Could we bioengineer microbes to turn carbon dioxide into oxygen? The idea is to unleash genetically modified microorganisms that can consume carbon dioxide and release oxygen as a byproduct, gradually converting the atmosphere into something more like Earth's. Carl Sagan thought so. The renowned astronomer and science communicator was a strong advocate for terraforming Venus, believing that it was a feasible, albeit challenging goal. In the 1960s, he proposed floating algae in the clouds of Venus. Sagan envisioned releasing genetically engineered algae into the Venusian atmosphere, where they would thrive in the sulfuric acid clouds, consuming carbon dioxide and producing oxygen. Others suggest using chemical processes like the Sabatier or Bosch reaction. These chemical reactions can convert carbon dioxide into methane and water, or even directly into carbon and oxygen, offering alternative approaches to atmospheric transformation. But maybe, we don't need to terraform the whole planet. Perhaps a more practical approach is to focus on creating habitable zones within the existing Venusian environment, rather than attempting to transform the entire planet. At 50 kilometers above the surface, pressure and temperature are almost Earth-like. The atmosphere is weirdly Earth-like. 25 degrees Celsius, breathable pressure. In this region of the Venusian atmosphere, the pressure is similar to that at sea level on Earth, and the temperature is a comfortable 75 degrees Celsius. But what if we didn't transform Venus? What if we adapted to it? Scientists think we could build giant floating cities there, airship-like habitats drifting in the clouds. NASA's Jeffrey Landis even believes these cities could run on unlimited solar power, never needing to touch the deadly surface below. It's wild, but maybe the most realistic way we could ever live on Venus. Massive solar-powered habitats drifting above the toxic planet. These floating cities would be self-sufficient ecosystems, powered by solar energy and providing a safe and comfortable environment for human inhabitants. NASA's HAVOC mission imagines it. The high-altitude Venus operational concept, HAVOC, is a NASA study that explores the feasibility of sending manned missions to the Venusian atmosphere, paving the way for future floating cities. So, could we terraform Venus? It's a question that continues to inspire debate and drive scientific inquiry. Yes, in theory. The laws of physics and chemistry suggest that it is possible to transform Venus into a more habitable world. It would require massive engineering, biological innovation, and centuries of work. The scale of the undertaking is immense, demanding unprecedented levels of technological advancement and international collaboration. Orbital mirrors, atmospheric conversion, floating cities, it's all possible. Each of these concepts represents a significant engineering challenge, but none are fundamentally impossible. But it's not easy, and it's not fast. Terraforming Venus is a marathon, not a sprint. It would require generations of dedicated effort and a long-term vision. Making Venus habitable means building an entire ecosystem. It's not just about changing the temperature and atmosphere, it's about creating a self-sustaining environment that can support life. Artificial magnetospheres to block radiation. Venus lacks a global magnetic field, leaving it vulnerable to harmful solar radiation. Creating an artificial magnetosphere would be crucial for protecting any future inhabitants. Synthesizing water from hydrogen and CO2, water is essential for life, and finding or creating a source of water on Venus would be a critical step in terraforming the planet, creating breathable oxygen in sealed biospheres. Before we can breathe freely on Venus, we'll need to create enclosed environments where oxygen levels are safe and sustainable. But what if there's already life in Venus's clouds? A tantalizing possibility that could change everything. Scientists have detected phosphine, a possible sign of life. The discovery of phosphine, a gas often associated with biological activity, in the Venusian atmosphere, has sparked intense debate and renewed interest in the possibility of life on Venus. Terraforming Venus might still be a distant dream, a massive undertaking meant for future generations. It's a long-term vision, one that may never be realized within our lifetimes. But before we imagine reshaping an entire world, we have to ask, should we terraform a planet we barely understand? It's a crucial ethical question, one we must consider carefully before launching any large-scale project that could permanently alter another world. Still, exploration is already underway. Even if terraforming remains far off, our quest to understand Venus, its atmosphere, its history, its potential, is happening right now. And that's where the journey truly begins. One of the most exciting steps in that journey is NASA's Da Vinci Plus mission, set to descend into Venus's atmosphere by 2031. It will deliver unprecedented insights into the planet's composition and atmospheric dynamics, helping us uncover how Venus became the way it is and what that means for our future among the stars. Veritas and Envision will map its surface. These missions will use radar to penetrate the thick clouds and create detailed maps of the Venusian surface, revealing its geological history and potential for future exploration. And floating probes are already in design. These innovative probes will drift through the Venusian atmosphere, collecting data on temperature, pressure, and chemical composition, providing valuable information for future missions. Terraforming Venus may be our boldest idea, a testament to human ingenuity and our unwavering desire to explore and expand our horizons. A second Earth, born from fire and acid, a symbol of hope and the potential for even the most hostile environments to be transformed into havens of life. Would you live in a floating city above an alien sky? A chance to experience the wonders of another world, to gaze upon a sky unlike any we've ever seen, or leave Venus untouched, preserve its unique beauty and scientific value, allowing it to remain a pristine example of a planetary extreme. Let us know in the comments. We want to hear your thoughts on the possibility of terraforming Venus.